Hey everyone! Today, we're going to dive into an amazing journey through the layers of the atmosphere. Ever wondered what makes the sky blue, or how planes stay up so high? Let's start to explore the invisible shield that surrounds our planet. The atmosphere is a layer of gases that surrounds Earth and extends thousands of kilometers into space. It plays a crucial role in protecting life, regulating temperature, and supporting weather and climate. The air we breathe is mostly made up of nitrogen, 78%, and oxygen, 21%, with small amounts of gases like argon, carbon dioxide, and water vapor. These gases help sustain life and influence weather patterns. Besides gases, the atmosphere contains tiny particles called aerosols, which come from natural sources like volcanoes and human activities such as pollution. The atmosphere is divided into 5 layers: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Each layer has unique features, like temperature changes and specific functions, such as weather formation, protection from harmful radiation, and providing a path for satellites. Let's start with the troposphere, the lowest and most crucial layer for life on Earth, extending up to about 8 to 15 kilometers. This is where all weather phenomena occur: clouds, rain, storms, and even hurricanes. Key characteristics of the troposphere include temperature decrease. As altitude increases, temperature drops at an average rate of 6.5 degrees Celsius per kilometer. Air pressure. The highest pressure exists here, gradually decreasing with height. Weather and climate. The interaction of air masses, humidity, and temperature variations result in dynamic weather patterns. Commercial airplanes fly at the upper boundary of the troposphere, called the tropopause, to avoid turbulence and adverse weather. Above the troposphere lies the stratosphere, extending from about 15 to 50 kilometers above Earth's surface. This layer is home to the ozone layer, which absorbs and scatters ultraviolet UV radiation from the sun. Key features of the stratosphere include temperature increase. Unlike the troposphere, temperature rises with altitude due to ozone absorption of solar radiation. Stable conditions, ideal for jet aircraft and weather balloons. Low turbulence. The stratified, layered nature of this region minimizes mixing, making it relatively calm. Without the ozone layer, life on Earth would be exposed to harmful UV radiation, leading to increased health risks such as skin cancer and environmental damage. The mesosphere stretches from about 50 to 85 kilometers and is the coldest layer in the atmosphere, with temperatures dropping to as low as minus 90 degrees Celsius. This is where most meteoroids burn up upon entering Earth's atmosphere, creating beautiful meteor showers. Key aspects of the mesosphere include temperature decrease. It gets colder as altitude increases. Meteor protection. Friction with atmospheric particles causes meteors to disintegrate. Low density. The air here is too thin to support human life without pressurization. Rising higher, we enter the thermosphere, extending from around 85 kilometers up to 600 kilometers. Here, temperatures can soar above 2,000 degrees Celsius due to the absorption of high-energy solar radiation. Important characteristics include extreme temperatures. Despite the high temperature, the low density means it wouldn't feel hot to a human. Auroras. This is where the northern and southern lights occur, caused by the interaction of solar wind with Earth's magnetic field. Space activities. The International Space Station orbits within this layer, benefiting from minimal atmospheric drag. The thermosphere plays a crucial role in radio wave propagation and satellite operations. The outermost layer, the exosphere, extends from about 600 kilometers to over 10,000 kilometers, gradually transitioning into outer space. This layer contains extremely thin air, mostly composed of hydrogen and helium. Key features of the exosphere include gradual transition to space. There is no distinct boundary between the exosphere and space. Satellite orbit. Communication and GPS satellites operate in this region due to minimal atmospheric interference. Low particle density. Molecules are so sparse that they can travel hundreds of kilometers before colliding with one another. Essentially, the exosphere acts as a gateway to interplanetary space. Now, let's compare these atmospheric layers based on altitude, temperature changes, and function. The troposphere supports life and weather. The stratosphere houses the ozone layer and provides smooth conditions for flight. The mesosphere protects Earth from meteoroids. The thermosphere hosts auroras and satellites. The exosphere marks the transition to outer space. Each layer has its own crucial role in sustaining Earth's environment and supporting human technology. Why are these layers so important? The atmosphere provides protection, shields us from harmful solar radiation and space debris. Climate regulation controls temperature and weather patterns. Breathable air ensures the availability of oxygen for life. Communication and navigation supports radio signals, GPS, and satellite technology. Understanding these functions helps us mitigate climate change, develop aviation strategies, and explore space. Remembering the layers of the atmosphere can be tricky, but don't worry, we've got an easy way to do it. Just think of this fun phrase: try some milk, then exercise. Each word in this sentence stands for a layer of the atmosphere. T for troposphere, where we live and where weather happens. S for stratosphere, home to the ozone layer that protects us from the sun's rays. M for mesosphere, the layer that burns up meteors before they reach Earth. T for thermosphere, where satellites and the northern lights are found. E for exosphere, the outermost layer that leads into space. With this simple trick, you'll never forget the order of the atmosphere's layers. Just try some milk, then exercise. Easy, right? As we come to the end of our journey through the atmosphere, let's take a moment to appreciate its incredible role in sustaining life on Earth. From shielding us against the sun's harmful radiation to shaping our weather and even supporting space exploration, the atmosphere works silently but powerfully, our planet's true guardian. So, the next time you gaze up at the sky, remember, there's a whole world of science happening above us, keeping our planet safe and thriving. Stay curious, keep exploring, and always look up with wonder.